Well, let's take a look at additional displays of quantitative data. Our first one is a frequency polygon. This is a graph that uses points connected by line segments to represent the frequencies for the classes. It is constructed by plotting a point above each class midpoint on a horizontal axis at a height equal to the frequency of the class. Next, line segments are drawn connecting consecutive points. Two additional line segments are drawn connecting each end of the graph with the horizontal axis. So let's take a look at example list in Excel. Say I have let's see, 10 through 19, 20 through 29, 30 through 39, 40 through 49, and 50 through 59. And our frequencies 7, 15, 23, 4, 2. Okay. Now, first step on creating a frequency polygon in Excel is put midpoints in column A, frequencies in column B. Now, they don't have to be in column A and column B. I'm actually going to put my midpoints right here. And remember the formula for your midpoints, you do equals, and then you add the current lower class limit, which is 10, plus the next lower class limit, which is 20, and then you divide by 2. So that gives us 15. Now, if I look over at my lower class limits, I went from 10 to 20 to 30 to 40 to 50, and then upper class limits, 19, 29, 39. It's going by tens. Our class width is 10, which means after I get my first midpoint, this will be 25, 35, 45, and 55. Now, it says frequencies in column B, but I'm going to put the frequencies right next to this. I think it works out easiest if they're right next to each other. You don't technically have to do that. Okay, then it says insert a row at the beginning and at the end with the appropriate midpoints. Use class width and put zeros for the frequency. Okay, so I'm going to use my left mouse button and click here and hold down on the left mouse button and drag over to here. I'm going to right click and say insert and then shift cells down. We want it to start at 0 for frequency, for a frequency polygon. Now our midpoints. See how this is going backwards? 35 to 25 to 15. I'm subtracting 10 over and over. So this one will be 5. And then we want it to end at 0. So we'll put a 0 here. And again, it's going by 10, so this would be 65. So we put a bogus data point at the beginning and one at the end to make sure it starts at 0. Now, I suppose if you already had one that started at 0, you wouldn't have to do this. Okay. Step 3. Highlight the midpoints and frequencies. So I'm going to left mouse click and hold down my left mouse and drag down to there. Then it says insert tab, scatter with straight lines and markers. So insert, scatter, and scatter with straight lines and markers. If you put your mouse over to the little description up here. And that gives us our frequency polygon. There we go. Okay. Let's talk about our next topics. Now, we saw these in the last section, so I'll just briefly touch upon them. Cumulative frequency distribution. Well, this is where you add the current frequency plus all the ones above it. Displays the aggregate frequency of the category. In other words, for discrete data, it displays the total number of observations less than or equal to the category. For continuous data, it displays the total number of observations less than or equal to the upper class limit of a class. Then our cumulative relative frequency displays a proportion or percentage of observations less than or equal to the category for discrete data, and a proportion of observations less than or equal to the upper class limit for continuous data. Okay, where's that used at? Well, the next graph we're going to look at is creating an ogive. This is a graph that represents cumulative frequency or cumulative relative frequency for the class. It is constructed by plotting points whose x-coordinates are the upper class limits and whose y-coordinates are the cumulative frequencies or cumulative relative frequencies. Then line segments are drawn connecting them. Additional line segment is drawn connecting the first point to the horizontal axis at a location representing the upper limit of the class that would precede the first class if it existed. Well, let's go see how to create this. And to be honest, I might as well just use my same data here. So I'm going to select that, right click on it and copy. And go over to sheet 2 and I'll paste it in here. Okay. Now let's talk about relative frequency. So down here, I need to sum these up. So I'll click down here and I will click the uppercase sigma auto sum. It'll guess, and if it guesses correctly, then you go ahead and either press enter or click this little green check mark. Now in our relative frequency here, I'll do an equals, and I'm going to refer to B2 because we're going to divide 7 by 51, and then divided by, and I'll put $B $7 to refer to that 51, and then times 100. The reason I put dollar signs before the B and 7 is when I fill this formula down, I always want it to point to B7. That's what dollar signs do, and I'll show that here in a second. So let me click my first cell here, put my cursor in the lower right hand corner till it becomes a plus. I click my left mouse button holding down and I drag down, and I get these. Now if I look at each formula, you see it says B3, B4, B5, and B6, but all of them refer to B7. Again, dollar signs before the formula cause it to always point to your B7. I'm going to press escape to get out of that there. There we go. Okay, those are our relative frequencies. Cumulative frequency. That's going to be all the frequencies. Well, I'm going to add this frequency plus all the ones above it. Well, this one's just 7. This one will be 15 plus 7. Again, I'm adding the current frequency plus ones above it. This one will be 23 plus 15 plus 7. Again, the current frequency plus all the ones above it. This one will be 4 plus 23 plus 15 plus 7. And I could use formulas for this, so it isn't hard-coded. But I'm just really wanting to demonstrate what is a cumulative frequency. And on this one, I'll add the current frequency plus all the ones above it. Like that. Okay, now our cumulative relative frequency. Cumulative, and I know these aren't appropriate abbreviations, but I learned the hard way. You got to be careful what you abbreviate on this. So here we're going to add all the current relative frequencies plus all the ones above it. Now I'm not going to type that one in, so I'm going to do an equals, and this one I'll say C2. Now this one I'll say equals C3, the current relative frequency, plus all the ones above it. So that'd be C2. Now we could also just point to the cell right above where we are. Now this one will be C4 plus C3 plus C2. So again, I'm adding the current relative frequency plus all the ones above it. This one will be C5 plus C4 plus C3 plus C2. Now you have to put equals before all these. And this is equals C6 plus C5 plus C4 plus C3 plus C2. Oops, there is no C1. Okay, yeah, I got all of them like that. Okay, now, first step. Put UCLs in column A, cumulative frequencies, relative frequencies in column B. Whatever you're looking at. I'm going to look at cumulative frequency. Okay, so here I want my upper class limits. Now, I'm going to just put age, but I'll put UCL here so we see it. Okay, so this will be 19, 29, 39, 49, 59. And this will be our cumulative frequency. And I'm not going to retype it. I'll just say equals, and I use my left arrow key to go over there instead of typing in D2. Like that, and then I'll fill down. Okay. Now insert a row at the beginning with appropriate UCL. I wonder what this do to the formula. Let me select that, right click on it and say insert and shift cells down. Oh, they're still the same. That points to D2, which is what I want. Okay, now I want this to be an appropriate UCL. If I was going backwards, my class width is 10. This would be 9. And I want it to start at 0. That's what they're indicating on that. Okay, highlight the UCLs and the frequencies. So I'm going to highlight these. I'll choose my insert tab, scatter, scatter with straight lines and markers. So insert, scatter, and scatter with straight lines and markers. And there's our ogive. This is a popular graph. They like this at Koch Industries. A lot of accountants did. Because when you think about profit, you got a company, and I always use this example. You got a company that's making $10 million profit a year. So you got $10 million. Was that good? You know, this is for, let's say, 2009. Well, a lot of people say, yeah, that's good. What are you talking about? Well, how about if I looked at 2008 profit, and it was $1 billion. Well, now 10 million, it's horrible. Company's doing horrible. If there's a reason why it went such a decline, then maybe you need to look at selling the company. On the other hand, if I change that to $1, well, then you say, "Oh, fantastic! They went from $1 profit to 10 million. That's doing great." Or if I just put in 9,999,999, I got $1 more profit for this year. It's not great, but again, it depends upon your industry. You know, if we're selling toilet paper, well, that's to be expected. You know, probably it's pretty uniform, your profits. You know, you probably don't sell a whole lot of more toilet paper this year than you did the year before. Not unless you do a good marketing campaign and convert people over. If you're talking about technology, well, this could be a bad sign. It could mean your technology is leveling off. Some new equipment's getting ready to replace it. 4GL's come out to replace 3GL, or Blu-ray is going to replace DVDs. So then you may want to think about selling it. So what's important is looking at the growth, and that's what ogive really shows you, is the growth. And you can see it's leveling off up here. You know, it's reaching our full amount. Try to get our data there. See how the biggest increase is right here. Went from 7 to 15 to 23, and then it's gone to 4, and now it's down to 2. Well, where companies like to be is they like to be with this high growth right here. You know, they don't want to be with the leveling off portion. You know, pass your company off to somebody else at that point. So anyway, that's what the ogive kind of shows them. Well, let's look at our last one. Time series plot. Obtained by plotting the time in which a variable is measured on the horizontal axis and the corresponding value of the variable on the vertical axis. Line segments are then drawn connecting the points. Let's take a look at this. Okay, so when we look at our profit, we got 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008. And you could have any kind of date there. You could have month, you know, whatever you want to track. And I'm looking at my profit. Maybe here it's 2 million, and 3.2 million, 4.7 million, 5.1, 8. 10, and then 10.1, and then 10.2. Okay, so it says put dates in column A, quantity in column B, whatever you're studying. Example, stock prices or something. Step 2, highlight dates and values. So I'm going to highlight these just like we have been, and then again, insert tab, scatter with straight lines and markers. So insert, scatter with straight lines and markers. This shows over a time series the growth of our data. So this is popular for anything relating to dates, so you can see how things are going. But that's a time series. I think that's the last slide. So let me find a recorder. Stop it. Then I'll stop the other recorder.